Something going on. Hey, yeah. Something going on in the neighborhood. Why do we see much further than we should? You're sick of the lies, sick of the lies. Who you gonna call when you get on the line? Who you gonna call? Who you gonna call? Who you gonna call? Yeah! GLOBEBUSTERS! 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 If there ain't no curve, there ain't no ball. The globe religion about to fall. We're gonna open your eyes so you can see who you gonna call if you wanna be free. GLOBEBUSTERS! 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 Who you gonna call? Who you gonna call? Who you gonna call? Yeah! GLOBEBUSTERS! GLOBEBUSTERS! GLOBEBUSTERS!
And welcome everybody to GLOBEBUSTERS. We accept the reality of the world with which we're presented. It's as simple as that.
Hello, everybody, and welcome to another edition of GLOBEBUSTERS Tech. I am your host, Zach, Good Times for All, and today we're going to be introducing you to the Flat Earth Smarts. Now, some of you old-timers, you OG Flat Earthers, you may have heard of this channel. You may have seen some of these already, but I know AJC 1844 has not put out a video in about 6 years. So there's a lot of people out there who have never seen any of his work. And it's not, flashy and catchy and short videos that are real easy to understand. It's some in-depth stuff. So it never really got huge, but it's great information, and he really can break down the sky for you. In the way that they did it in ancient times with a planisphere, which is really cool. So before we do that, we are going to introduce the panel. I would like to start off with Miss Karen B. Karen, how are you doing this evening?
I'm doing great. Happy to be here.
Awesome sauce. How was the week? Are you ready for the eclipse?
I'm getting ready.
Getting ready. Awesome.
I'm getting ready. I have on the other side here, I have all my gear all staged out, and I'm like making sure I have all my batteries, all my chargers, all my filters. I have so much stuff now. I was like, wow, I've really amassed a lot of video stuff. So hopefully I do something good with it.
I don't feel like I've ever experienced so many eclipses at all in my entire lifetime. Yeah. I thought this was supposed to be a really rare, once in 100 years kind of a thing, but all of a sudden, we're getting 3, all of a sudden, just like that. It's what? You know what
they
I mean?
happen pretty often. They're just always in a different part. They're just, it changes. So that's all. We just got lucky with waking up to flat Earth and then having 3 total eclipses.
Yeah.
Across the U.S. So, yeah.
It just feels like they're becoming more and more frequent all of a sudden.
Well, after this, we're not going to have any more in the U.S. for quite some time. See, this is the last one for 20 years that'll show up here. And then it's going to start being in Africa and Indonesia and Australia and stuff like that. out in the
Uh-huh.
ocean where no, like there hardly is anything. Well, as far as
Yeah.
we know, you know. So
Very cool. Yeah, I can't wait to see the footage you guys get and all that kind of cool stuff. So
mm,
good luck. I hope the weather works out for you guys. I'm going to be
so far it looks like it
bursting
will.
clouds.
Yeah.
Pull up those polarized filters and see what you can see, like under the different polarized effects.
Oh yeah, we're having everything we can. I just won't have that really cool hydrogen alpha filter that Crow and Chris have, but so they'll get something totally different. Probably way cooler than what I'll get. But I'm still gonna record and see what I can find. It's always fun. I want to try to record more of the different effects of light that happen during the eclipse, like the light banding and like the different
Yeah.
type of shadows.
Hmm.
So I really want to get some good stuff of that this time because last time I wasn't really focused on that. I was like just looking at the sky. So I will look at the sky during totality, but before and after you get some really cool effects with the light. So I'll be looking
Yeah,
at that.
awesome. I can't wait. I can't wait. And Kyle, how are you doing, sir?
Doing
Mr.
really
Kyle
well. I've been on the warpath with Newton's laws of motion, and it's been really fun
Adams.
just talking about this. And I've been going up against like some of those really, really stubborn globe earthers, and it's just nice to see like how we are able to actually reach resolutions, right? Because so many different debates, you never actually see a resolution. They're just saying, oh, well, they take their stance and you never watch them change their position. But here with my whole common ground approach, where do you agree about this? And if they say, no, I don't agree with that, you just ask them a more basic, stupid question. And like the more they disagree, the stupider your questions have to get. And yeah, until they get to a point where they're denying the nose on their face, kind of a thing. You know what I mean? And so, yeah. And then you find that if you can, hopefully with this approach, it comes to a point where they're not doing that, but they're like, yeah, you got a point there. You're right. And you can actually watch this whole transition take place where they actually change their mind. And that's just amazing to see. And yeah, if no globe earthers ever change their mind, then there would be hardly any flat earthers out there. Cause most of us were all globe earthers at one time. Right.
Oh,
So,
yeah. I
don't
said
give up
flat
on the
Earth
globe
was the
earthers.
dumbest thing I'd ever heard of. How could people be this stupid?
Yeah.
You know, I said that. It was the first thing that came out of my mouth. I was programmed to say that. Yeah, they got me.
So never give up on the globe earthers, no matter how stubborn they are.
All right. And finally, last but not least, this is Cammie Nodell. Cammie, how are you doing tonight?
Oh, I am doing okay. I'm hanging in there. I have to say I'm a little bit jealous. Now I haven't been, and I have not been motivated to do anything. But now that the eclipse is coming there, I'm remembering back to the last eclipse, the sweet memories where we did launch the balloon, and I'm thinking about the experiments people are doing, and my mind is racing, and I'm loving it. I'm loving feeling a little bit of the excitement again. And so this is for any of the nerds that have the Hydrogen Alpha Solar Telescope. And that is when talking with the polarized filters, we're not talking about what we're visually seeing in the sky, but we're talking about what these people that have the second sun, that people have the Hydrogen Alpha Solar Telescopes are picking up on. And that is the image that they're able to polarize out. So I have an experiment for any of those that if they do get that second sun, that they can polarize out. During the eclipse, which it should also naturally polarize, your experiment would be to take a polarized filter and hold it at a slight angle, about 23 degrees in front of it, and see if you can bring that sun back. Once it's gone from the eclipse, you should be able to, again, if we're working with polarization and doing it much like doing that third filter when you have it out, it should be able to be brought back in there. And so any of those lucky people that have, when I say lucky, I mean people that have done the work and the study and are running and doing all the stuff with this telescope. Love to see, as many results as possible from this. But
yeah, it's getting exciting.
It's starting to get exciting, yes.
And is anybody here on the panel worried that the world might end? That, this is going to be the bringing the doom and gloom of, I mean, I've never seen the government act
No.
so crazy about this. Do you think it's because of all the mayhem that might have happened the last crossing? People going to all these cities and
I don't
clogging them,
remember that
maybe?
being a big deal, though.
I
Do
don't
you?
either. No.
I mean, I wasn't my house was not in the path of totality, but I had to drive like an hour and a half south to South Carolina. And I just went on the map and I just picked some random park that seemed like it was in the middle of nowhere, but in the path, like basically in the center of the path. And I drove to it, and there was like 15 or 20 other people hanging out there. And it was like not a big deal at all. So I don't know why. I mean, leaving, it was kind of a little bit trafficky because everybody was leaving at the same time afterwards, but it wasn't that bad.
Yeah, I mean, they're shutting down schools. And I remember being at school, being able to go outside and watch the solar eclipse through, we did it through a pinhole thing,
Mm-hmm.
and we watched it happen. I remember
Pinhole
that as a child.
projectors.
Yeah.
Solid proof that the light from the sun is not parallel. If all the light from the sun was parallel, those things would not work.
Very true. Very good point, Kyle. So yeah, I've never heard all the doom and gloom around an eclipse before
Mm-mm.
like this one. It's really weird. It's just
yeah, it's kind of ominous with it being on an election year. You know what I mean?
I think, yeah, just anything to distract from what they're doing. I mean,
Yeah.
there's
Yeah.
all kinds of horrible things that our government is responsible for, and I don't want to get into it. I think we all know what's going on, but
Yeah.
I mean, they act like we're not already at war, but we're basically like doing war type stuff on the other side of the world with multiple countries. So it's like,
yeah.
look over the eclipse, go buy stuff, get 2 weeks worth of water, let's freak out.
Make sure. I'm surprised there's still toilet paper on the shelves.
I know,
Yeah.
right?
Yeah. Oh my goodness.
There's still people that have a stock of toilet paper from back then, I bet.
One of those big epic moments
That's like
that
4
just
years ago now.
I know.
go down in history, right? That's epic moments in history. The toilet paper shortage.
Oh, so dumb.
Oh, geez. Okay, well, yes, everybody, if you're traveling, I hope you have safe travels for the eclipse and all that good stuff, and I hope you get some great footage and the weather works out for you. Yeah, this is cool. I can't wait to see what you guys get. So now on to Flat Earth Smarts. Like I was saying earlier, the channel is, let me jump over here real quick, is AJC 1844.
1844.
Yep. Only 14 videos. They're the smarts, he calls them. And about 2,000 subscribers. But yeah, he hasn't done anything. Let's see. His last video was 6 years ago. And there's the videos. So we're going to start off with his trailer. It's kind of just an explanation of what he was planning to do. I was actually...
Amazing. Sorry, I was just gonna say it's amazing he was able to get 2,000 subscribers with only 6 videos, or that's more than 6. Sorry, with only this amount of videos.
Yeah,
So it's not very many.
yeah, no, they're that good though.
Yeah,
These are one of the things I've promoted multiple times throughout the years, and it's really amazing. A lot of it has to do with the sun and the moon, and yeah, over a planisphere and how it really works. And some of the other things are the philosophy, I believe, the psychology of all this stuff that's going on too. He kind of dips into a little bit. But yeah, so we're going to check out his first video here. Are you guys hearing that?
Mm-hmm.
Okay. Here we go. AJC 1844 idea.
that the same bridge that just broke, or just one that looks like it?
Yeah, that was just kind of his like trailer, I guess. Yeah. So let's go back here. So the Flat Earth Smarts, we're gonna let him talk about it. This is more like the intro. That was really a trailer, like just a trailer, like a movie trailer almost. I forgot all about that one. Yeah, so I believe there's 13 smarts? 14 smarts. Yeah. 1, 2, 3, 4, 5. Where's 5? He removed 5. I'm sorry, everybody. I was just looking for 3, 4, 6.
What was number 5? Do you
I'm
remember?
not sure. I know. It's been so long since I've seen him. I'm not sure. I asked him a question, I think about 2 years ago, year or two ago, and I didn't get a response. I don't even know if he still has Skype, But yeah, I've talked to him a couple times. Very smart man. Very smart man. So yeah, we'll play this one. This is where he actually, his welcoming, where he actually speaks.
Welcome to Flat Earth Smarts. So, you think the world is flat. For what it's worth, so do I. Why? It's simple. It looks flat, and there's nothing can be done to prove otherwise. If there was, the scientists would have done it a long time ago. The fact remains that they can't. So, where to from here? Let's get something out of the way before we go any further. It'll save the naysayers watching further. Flat Earth Smarts will not provide some magic proof that the Earth is flat. I came to Flat Earth a few years ago. Don't concern yourself with how, except to say that I was on board with this when the story broke 2 years ago. And it afforded me the luxury of being able to sit back and watch it unfold without the need to weigh up the arguments. So why this now? Because there's not enough hours in the day. You undoubtedly walked into this without expecting it. You didn't go to school to learn about the Earth being flat. You didn't attend a college course to find out about it. Most likely, you were bumming around on the internet or killing time on YouTube and decided that you'd have a look at this ridiculous idea and shut those dumb flat earthers up once and for all. If you're like me, you grew up on a globe. This is one of the few subjects that are taught from a start position of ridicule. How many of us heard those stupid people in the olden days thought the Earth was flat? Aren't they stupid? Well, guess what? It's 2016 and there's more questions now on the subject than there ever have been. I won't belabor you with them for a moment. As I said a moment ago, I don't have the magic proof, and I don't have a silver bullet that will kill the globe either. It's undoubted that YouTube has provided many of us, myself included, with lots of things to think about. So what's to be done with it all? There are not enough hours in the day to watch and think on all the people have to say on the subject. Maybe it's time to get smart on how we look into it. If you let YouTube lead you, you'll be bounced from one opinion to the next. None of them will agree with each other. Some will have good points, and some will be not so good. So, at the risk of sounding all biblical, how to separate the wheat from the chaff. If you've just come to this, perhaps the best suggestion is to turn off your computer for today. Go to bed with a warm drink, and wake up ready to start on it tomorrow. If you've gotten this far, one more night and a good sleep is not going to stop you here. You will not find the answers if you stay up looking for the one video that will answer the matter. When you wake up in the morning, you can start and you'll have the rest of your days to look for some answers. But before you do, there's a few questions that you can answer, and you won't find the answers on YouTube or on the internet. If you can answer these questions for yourself, you can steer your own way through this maze, and hopefully you won't be swayed a long way by anybody else. Can you put everything you've learned about the world to one side for a while and look at a subject with a clean sheet of paper? Can you accept that what you think you know about the world might be wrong? Can you accept that everyone makes mistakes, even scientists? Can you believe in something that nobody else seems to completely agree with, or that people think is plain dumb? Can you form an opinion based entirely on things that you have discovered for yourself? Can you hold a belief that is unpopular among the people that you believe you know well? Can you make a decision about a hot topic and defend it? While answering yes to these questions is a good indicator of how well you know your own mind, don't be put off too much if you're wavering on a few of them. Remember, you don't have to paint your beliefs on a banner and parade them down the local high street. First and foremost, they will be your answers, and nobody has the right to question them. Once you're settled in yourself, the journey gets a little easier. So, I'll leave this here for now and add to them as time goes on. Oh, I know you opened this expecting to find the clinching answers to all your questions, but like I said, I don't have them yet. But let's see if we can smooth the way. By the time you watch this, I'll have uploaded number 2, and you can start there. For what it's worth, let's hope you learned something towards navigating your way through the flat Earth. I'm not really concerned with what people think of this video. If you find it useful, you're welcome. And if you don't, then you spent a couple of minutes listening to some bloke whittering on about nothing important. I'm also not too concerned with what people have to comment on what I've said, but I can't help noticing that some people seem to have an irresistible urge to comment when they watch a video on YouTube. So, for their benefit, I've left the comments running. And I've put my email details at the end too. My name's Adam. Have fun on your journey around the flat Earth.
That's how I got a hold of him right there.
Yeah.
Yep.
Wonder if he's still around, like if he'll still respond or something like that. He'd be kind of fun to interview sometime.
Yeah, he's done some really, really great work.
Yeah, just that whole video there kind of got me thinking about my early days and just kind of red-eyeing it, just because once you like start to really look into it, it's just like this big, huge snowball. You're glued to your computer for days on end, and just one thing after another if you know where to look.
And that was the thing back in the day, you could actually do that. Now there's so much censorship.
It's hard to find other Flat Earth channels out there, which is why you need the Flat Earth Clock app.
Yep. Flat Earth, Sun, Moon, and Zodiac Clock app by Blue Water Bay. make sure it's by Blue Water Bay, because if it's not, it's going to be some crappy ripoff that nobody else is on, and you're not going to be able to use all the cool features and all that kind of stuff. But yeah, for sure. Yeah, there's a couple in here though that are just, I mean, if you guys have the time, you know, and you can just, I mean, the visuals are pretty cool. You could tell he took some time putting them together, but really these are things you can just pretty much listen to. He's not showing you anything you really need to see, you know. In the earlier ones, I know once he gets up, he starts talking about the stars, and this is the one that really just broke my brain. He talks about the way that the moon moves and things like that. I don't know if he has one on.
When it comes
Yeah.
to like the sun's ecliptic and the moon's ecliptic, that one kind of like, I never quite thought about it that way before, and it just kind of really makes so much sense. Makes so much sense when it comes to star trails and how they work and so many other things. And like when it comes to like talking with globe earthers, oh, you guys can't navigate on your map. It doesn't work in navigation. And it's like, okay, there's a lot more on like flat earth maps that they're not quite seeing there. And when it comes to like the prediction of star trails right there on the flat earth map, that works phenomenally well.
Yeah, yeah. So I'm just gonna click a couple of these random ones, and we'll just watch a couple minutes of the beginning of it. Proofs, not personalities. Yeah, he makes a lot of very good. See, this was near the beginning when people were, you know,
I
trying to make
actually
it.
watched that one today, and he takes a shot at Mark in that one.
Does he really?
Yeah, he does.
Uh,
He's
Yeah.
like, if you think the earth is flat just 'cause nice Mr. Sergeant said so, and I was like, oh, shots fired.
There's a lot of them that are full of fluff though. They're just like kind of waiting for him to get to the really good big points. But once he does make the points, they're really potent. You just got to get through the fluff.
So Map Schmaps, that was a he made
Yeah, I
a
haven't
couple that
watched
were
the
a little bit
longer ones.
longer. Yeah.
Probably
Those
the
are the
longer
ones where
ones are
he
the
really gets into it. Yeah.
yeah.
It's not just him talking. So we'll take
No,
a
yeah, I liked working with Adam because Adam and I had different sky models and we still did. But what made him unique and fabulous to work with in the early days is even though we had different opinions of what was going on in the sky and different solutions, we could work with each other. It wasn't about proving each other wrong or whatever. It was about discussions, what you could learn from each other's things, what you could pull through. And that type of discussion, that type of intellectual discussion where again, it's what you can learn instead of can I be the right person? I have to be the right person in the argument. It's a whole. It's so refreshing and so wonderful. And so his videos were actually award winning as a good starter video set at like one of the conferences. We gave him like a best starter video award on it. Even he put out really good solid stuff in Anon. It was a good thing. A nice niche. It was for people that if you didn't want to do overall conspiracy baits, if you wanted a video to show your grandmother or your, somebody for, you know what I mean? Somebody where you didn't want to pull in other conspiracies going on and doing things. It stayed focused on flat earth. It was clean. It was exaggerated. It just was common sense to everything. It was brilliant. I think he was a 5th grade teacher. I'm trying to think what grade he did teach before retiring. He's genuinely one of the nicest people I know on Flat Earth. He might come back, but he does not with like all the back and forth. He wants to teach. And I think unless he had something new to teach, I don't see him coming back to be popular. That was never his it was never his feel, to be popular. I think most of his stuff has stood the test of time extremely, extremely well. And again, even the things that we disagree with, I'm not. He has some, fabulous, fabulous pieces on it. I wouldn't say that, oh, I'm right and he's wrong, because they're like just different ways of looking at it. And again, I think things should be looked at in all possibilities, as long as the possibilities are working possibilities that work with reality.
Mhm.
And he did employ that filter. He did a good job with employing that filter. I'm sorry he name called Mark, because I think
He didn't name call him. He just
or just, you know, did the thing that people did in the, you know, because that was probably a little bit out of character for him when talking with him. But yeah, I enjoyed Adam a lot. When Zach said I want to cover Flat Earth Smarts tonight, it's like, loved Adam, loved his work and his stuff. Wish he would come, you know, back out on the scene a little bit. He was refreshing.
I never did. I never got to talk to him, so I don't know.
Shout out to
He
the
was-
different Flat Earth school teachers out there, because
Mhm.
we know you're out there, and
Yeah, that's cool that
Yeah.
he's a teacher.
yeah.
And with the teacher, with people early on, he's somebody I probably worked more with than other people early on in it, until he stepped away from it. But yeah.
Yeah, one of the committee members for the Utah Flat Earth meetups was a school teacher, and she's kind of hanging in there. She's like, she feels kind of bad about teaching people about the globe, but you know that there's a lot more to school than just that, and so she kind of hangs in there for
Yeah.
all these other reasons. And yeah, but yeah, it's nice when educated people out there know about the flat Earth.
But even so, if they're you know, careful with their words, if they choose the right words, they can still, you know, be like, the theory, the heliocentric theory is,
Yeah,
you know,
Yeah,
They
there was
were
a
able to
physics
still-
teacher in BFE North Judson, Indiana, which is like one of the smallest. It had 2,000 people that lived. Not at that time, though. By the time he retired, there wasn't even 2,000 people that lived there. And he taught in every one of his science classes that if you can teach me that the Earth is either moving or round, you get an A in the class and you never have to do any work or take any tests or anything like that. And he would do that with every single class. He's like, all you got to do is prove it.
that's funny.
And yeah, nobody ever did, of course. But
Hilarious.
yeah, he tried to get kids thinking that way. You know, he couldn't come out and say, hey, the Earth is flat.
Mhm.
And
Yeah,
they're
but once you do that, they
they're all lying
really,
to you.
that's when science becomes alive. And so, yeah, all of a sudden, yeah, that's quite the catalyst there for getting things started when it comes to science. Because so many times, like for me in high school and even in college, like a lot of like geography and geology, that was the boring stuff. It didn't matter. Like why should I even care about this stuff?
Mhm.
Yeah, but then all of a sudden, yeah, flat Earth comes along. Wow, that is so fascinating. Tell me everything you know about it. Yeah.
Thank you, Nick. Nick.
I'm pretty interested in geology now, though. After flat
Yeah,
Earth, that's like
yeah.
one of my main one of the main things I look at.
And I actually worked with an old retired geologist who said, you know, things were kind of set in stone there for a while on how things worked. And then in the 60s, everything changed, he said. That was like he was teaching in at some college or something like that at a university at that time. And he said it was really, there was a lot of debate whether tectonic plates were even a thing, and like all kinds of stuff was really changing in geology. So yeah, it's definitely not a science. Those are the ones that they're taught, you know, it takes millions and millions and millions
Yeah,
of
their
years.
timeline is really stretched out, but I like to look at their stuff because they talk about how things could have formed, and then I just picture it happening in my mind, but just at a much faster scale.
Yeah.
And
Yeah, because
I'm like, could have been.
there's a lot of in-depth thought. Like he knew, he was like, okay, so if you take a core sample here and you find this kind of rock, and then you take one here and here and here, and then eventually you'll find this kind of rock, you know that if I go the other way, I'm going to find this kind of rock because of the way the things came up through a crust of some sort, or the way things formed. Geologists, that's what they're taught, like where you're going to find the other stuff
Yeah.
around that. Yeah, it's really amazing, the whole world of geology.
And geologic folds are something I really like looking at. I don't know if you know where like the mountain is like zigzagged and like it's hardened that way. Like it, you know, it's insane.
Yeah, we got a lot of those
It's
around
really
here.
fascinating.
Yeah. Yeah.
It's beautiful to look at now, and it's ironic too, having a background as a gemologist, but geology and earth science in school bored me to death and to tears. I wasn't drawn to it. I wasn't interested. I did like to go out and look at rocks and things like that, but I didn't connect the two when I was in school. What they were trying to have us memorize or do things with the geology and that, again, I couldn't connect it to reality, and maybe it's with the millions of years and the numbers that you had to memorize, and it probably wasn't the teacher and the way it was presented. But I do love geology. I do love looking at the facts, and I love looking at it now as a puzzle. And it must be the art of teaching, because you would have thought that would have been a favorite science, and it wasn't. I liked chemistry. I liked chemistry a lot. I liked mixing chemicals a lot. And
See, I didn't get to do any of that. That's why I couldn't stand chemistry, because it was all math. That's all we did was math. And I got straight A's in math. I told them, I was like, are we ever going to get to play with anything, or can you give me something else to do? Because I'm not sitting here in class and doing math problems for you. I just did
well,
that.
geology, had they let us go out and dig, it would have probably been a whole lot different than learning this stuff.
Yeah.
At least chemistry, you got to have a lot of mixed chemicals.
And then they add the whole in millions of years ago, blah blah blah, 14 to 15 millions of years ago, da, da, da. And when you think about it in those kind of terms, it's really not interesting at all. But when
It's
you think
true.
about it in more realistic terms, and when you know that these processes can happen way, 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 way faster than they would lead you to believe, because it just pushes their whole evolution, space, Big Bang stuff, right? They have to drag it out over millions of years, right? But actually, if you just watch, the world around you, you can see that the land is always changing. Things are always happening. Erosion's always happening. When houses are falling in the cliff because the ocean is beating on the cliff, like this stuff, it's always happening, you know? And so some of these things, it's like they happened, and it's just not if you think about it in a shorter time frame, and you know that things can harden really fast, and if you look at impossible fossils and realize that bond, it can happen a lot faster than they would like you to believe, you know.
And it's obvious, though, again, if you go outside, it makes me mad that the touch grass, they were playing it on the Biden party or whatever, telling people now to go out and touch some grass. And I guess maybe don't touch grass, touch weed. Weed, or touch nature, touch a tree. But if you walk by a riverbank, and I did, that was one of the first things I did with Karen B, who had such a beautiful riverbank to watch by. But you can see things midway along the way, crystals growing and things fossilizing, roots fossilizating. You can take a rock in one hand and hit along some tree roots along the banks that are still growing, and see that they are turning to stone, pieces of them. You can catch it in progress. Look at the impossible fossils and start looking at any of the events, any of the volcanoes that going up, and see how many millions of years of history take place in an instant.
Mount St. Helens was a great example.
Was perfect. It was a perfect example of
Like,
it.
look, it made its own little Yellowstone right there, kind of, with
from
all
1
the
to
sedimentary
2.
layers and all kinds of stuff. And yeah,
I always find it really amazing, just the lasagna layering when it comes to like the dirt and the different levels of the earth, and how can you really explain all of this layering just happening on its own? You know what I mean? Like, it's like, oh yeah, this whole lasagna here just formed on its own under natural processes. Yeah, right. You know what I mean? Yeah. It looks like someone, like, when it comes from my garden anyway, like I have to like go out, and it takes a lot of effort to make those layers in the dirt.
oh yeah, well, when you're moving 100 to 500 tons or whatever, that amount of earth, and it's just rolling down a mountain, it kind of just figures it all itself out. Density and
Right.
buoyancy
Just
kind of figures it all out for itself.
Yeah, I'm just thinking of like a whole like layer of white rocks, and then on top of that, a whole layer of red rocks, and then going back to another layer of white rocks. It's just like you think that just happened, just poof, just like that, just yeah, or of natural circumstances. There's certain things out there I just can't say that's natural
Well, I mean,
circumstances.
well, if I mean, it's natural because it's there.
Yeah,
I mean, I don't think anybody's making
but just
layers.
happening by itself. Like yeah.
Well, yeah, it's interesting when they talk about the different processes. If you read like in some of these rock groups and these geology groups and stuff, and they talk about a lot of like glaciers, and there's actually a lot of floodplains over that. They talk about, oh, there was a flood here, blah blah blah, and it's really interesting how a lot of it, well, most of it is related to water, large amounts of water, which kind of corroborates the whole historical flood story that so many places have. And so actually a lot of it is it's kind of a trip when you think about it.
But my question is like, where did the rocks come from? Okay, you get like a whole layer of white rocks, and then so that's what you're seeing there for I don't know how many years, and all of a sudden, where are all these these black rocks on top of it? Okay, you see a whole bunch
It's
of
the
black rocks on top of
ingredients
all these red
It's
rocks.
the ingredients available, what would decompose at the time, and what ingredients
Mhm.
would be available with the water and that to turn into it. But again, they grow from the elements that are available. And the fact that your program that they grow over millions of years or hundreds of years or thousands or again, whatever timeline they're giving you. I know the reality of gemology showed me that we grew them in laboratory, and then flat earth where we took it further and took it out to other technology, because the one thing that we were doing is growing little ones fineness for rings and little baubles. You see what they're doing with radio technology and how they produce quartz in laboratory, and that
Mhm.
again point out large pieces in a matter of days and weeks, hours, and sometimes on a lot of the stuff. Again, metals, they crystallize in milliseconds. They crystallize so quickly that we can't get them in a non-crystallized state except for with our very, very best technologies. So again, the idea of these things taking hundreds or thousands or millions of years, when you can watch it literally, you can literally watch a crystal grow in front of your eyes under a microscope, or again, do some of the metals that they do it
Mhm.
instantaneously. Reality is beautiful. Part of what they're hiding when you spend all of your time wired on, and the evolution, everything, again, when you hide what you're really looking at and build the backstory and make heaven unobtainable so far, far away,
Here you go.
you lose the beauty. That's the number one thing you lose.
This is what we learned from Mount St. Helens, it says. This is from answersingenesis.org.
Oh, that's Danny Faulkner's territory.
The eruption of Mount St. Helens 40 years ago today still provides an amazing opportunity for scientists to study the effects of a catastrophe. The event on May 18th, 1980 is often regarded as one of the most significant geological events of the 20th century. The incredible lessons are as valuable as ever. Geologists who are accustomed to thinking about slow evolutionary processes shaping our world were astounded by the scale of initial destruction and the speed at which new geological features were formed. 40 years later, Mount St. Helens still teaches us lessons about the powerful forces the Creator uses to shape the Earth. These findings confront the underlying slow and gradual assumption of modern geologic thinking and give us an invaluable clues about the catastrophic potential and consequences of a global cataclysmic flood. So that's what Karen was saying earlier. If there is a flood like that, that's how you're getting all these different layers. Like
Mhm.
Mount St. Helens kind of proved that all of this can happen. It doesn't have to be millions of years to build up all these different sedimentary layers. When it happened on Mount St. Helens, when that whole mountain, the side of it came out and went down into that valley, it layered itself into its own sedimentary layers. It acted almost like a liquid, like a liquid of different densities. And as it went down, so you have all these, it looked like it was, 10,000 years, 5,000 years ago, 1,000 years ago. No, this just happened a week ago, and it's in all these different layers already. So yeah, that's what if there was a giant, huge cataclysmic flood that covered most of the Earth, yeah, I could see sedimentary layers being all over the place.
Mm-hmm.
You
Also,
know?
and like a lot of the fossils, like ammonite fossils being found inland all over the
Mm-hmm.
place. And another one of the most common fossils is this type of plant that's an underwater plant that it like has those weird little rings, right? And then like the flowery top, and and so they find those all over the place, all inland. So it's like evidence that all of the land at one point was under large amounts of water. That's why you find like all the sea creature skeletons and stuff. I think it's it's like it actually answers a lot of questions to the like why you find like seashells and stuff on mountains and shark tooth. You could still go into like the rivers and creeks around here up and down, in the Appalachian Mountains and find shark teeth, you know.
Mm-hmm.
The Australian
So
Museum, they're the ones who came out and said that fossils cannot form without a flood.
yeah, you
Fossils
need
cannot
a
form without
flood.
a flood.
Like
Yep.
like the petrified forest that's in Arizona, right? Like okay, so that's how petrified wood forms, right? It's underwater in a highly, a water and mud, right? It's going to have all those minerals and stuff in it. It's like creating a super saturated mineral slurry, and because it's underwater and it's the oxygen's not there for the wood to rot, it then starts to decay under the water, and it slowly over time the minerals replace the organic material in the tree, and that's how you end up with the tree, the petrified wood that looks all pretty and it's opalized, or sometimes it's quartz or agate or whatever. But it's like, but you can
Mm-hmm.
tell that that at one time was wood. We know how to
And Karen,
positively identify petrified wood.
she does it. We know how to do it. And the way that she's describing it is absolutely perfect. You have the gift. You have the gift of verbalizing exactly how it's happening. And I couldn't appreciate it more. Pay attention if she put it very clearly, but a lot of people think that when things are petrified and they think of desert, they think that things petrify in the desert, in dry conditions and that. No, that happened underwater, and that, in other words, dehydration and fossilization
Mm-hmm.
is completely different. Dehydration is going to, pretty much turn to dust after it. The water is going to
Yep.
go. It's going to flake. It's going to it's going to wither away. You could have a husk of it left. If you see something that's dehydrated, again, if you found dehydrated bones or that, again, you'll have a husk of it, but it's not the same as if it's fossilized or petrified, like your petrified forest, where again, this happens in a wet condition, and it's usually a still condition to keep the outer shell of it's not getting disturbed. But it's the recipe of what's dissolving and the moisture and everything working around and growing the minerals to replace what's there. It's a replacement,
Mm-hmm.
not a drying out a husk of it. So that's why, like, again, with it's happening all of the time around you, not over millions of years. And again, very, very misunderstood. They don't really point to the fact. I still think that most people think that it's something that happens when it dries out, and that's completely the opposite.
Mm-hmm.
Petrified
Can other
forest.
low oxygen environments under pressure also form fossils? Probably. It's possible.
Say that question again.
Said, could other low oxygen environments under pressure also form fossils?
They can, but again, the under pressure and everything, they talk about, like with diamonds, they talk about diamonds being formed under high pressure and high atmospheric pressure.
You don't really need that high pressure.
And well, not only do you not need it, but again, I was in the industry when we were learning all of these things going on, and I was in a position where I needed to identify, for laboratory, I needed to identify what was happening above ground versus below ground. So I got to learn a lot more of the geeky stuff about the above ground. But let's look at it again. Say the exact question again.
Other low oxygen environments under
Yeah.
pressure also form fossils.
Right.
Dehydration.
The key to it was, the key to it is that we formed diamonds better under low atmospheric pressure. When we did the high atmospheric pressure, it was under a process called HTHP, high temperature, high pressure. And there was some success in it, but we exploded a lot of them. We grew faster and more and better and more effectively under low atmospheric pressure. But see, Superman had already been written, and they'd already said that the way that you made a diamond was to take Superman to take coal and squish it in his hand and compress it. And that high pressure is what made a diamond, when in fact it has, again, if you took a piece of coal, you squeeze it, you're going to have a shattered piece of coal. It's how it grows. It's how it forms. So the entire basis of all of that is unnecessary. You don't need
Cam,
the
you
high
just don't
pressure.
understand how much pressure he can squeeze it at.
Right. For those that don't understand how crystals grow and how lattices work, this is to me the absurdity of the way it's always been watching that. It is kind of like saying, I want, in Tinker Toys, I want this little tower condensed that has smaller sticks and like the little pieces between it, and it's 2 inches tall. So I'm going to take a 10-inch tower and I'm going to crush it and compress it into that. Everybody knows if you take a press and compress that little tower of Tinker Toys lattice, you're going to just crush the fuck out of the lattice. You are not going to get that little container. It's not how reality works. So
that's a really good way of describing things.
I see things in visual in my mind as they're happening. They weren't Tinker Toys, but when you see lattice structures of gemstones and that, Karen, you could see how my mind is building little Tinker Toys. And in fact, Zach, I made you build things not with Tinker Toys, but with toothpicks. And but Tinker Toys would be, I
was going to say the whole function of water when it comes to making a fossil is about transportation. It's got to be able to take the minerals from someplace else and put them somewhere new. And that's how fossils are.
It's not, no, it's a slurry. It's a catalyst. It's the water, and it holds it. Not, it's not transferring them. It's actually holding it. It's a, you're saying transfer, but I'm saying it's not.
Well, it's got to replace. It's a replacement, isn't it? Fossil. There was a bone here, but now it's being replaced by different minerals.
Well, okay. Look, the reason it's being replaced by different minerals is the minerals. Okay, your pieces of the body breaks up into different elements. There are different other elements in the water, and there's other like plants and other things. You know, again, different things becoming available in this recipe. Then you have in the case of like a tree or a person, or again something that becomes fossilized. On it, you have something that has a hard boundary on it, right? So as it's decomposing, sitting in, again, why in air, and you'd have pressurization and getting dehydrated, you could see how it would just fall. But if you say, like, again, it's the water takes the pressure off of it. So you have a still condition. As these ingredients become available, it's like, hell, these conditions are all ripe to grow these crystals. What decomposed, what's those chemicals that broke down from whatever the tree decomposing, again, the silica, the different things becoming available in the actual gut level elements mixing with the other things. It's a recipe. These elements are all now in the same place, and they're in a super saturated slurry, because where that tree is, like in the water, is super saturated. It's a thicker area than the clear water next to it, and you don't have things breaking the boundary, but all of a sudden it has more ingredients available. And those ingredients, naturally, when they're present, they only know how to do one thing. They know in nature how to grow. When the temperature and all of the ingredients and everything are present, when the right things are present to grow, the conditions are right, they will grow. Just like snow will change and do into a snowflake when the temperature and the conditions are right, your moisture. When the things are present in nature, they only know how to use them and do it. The impurities that go into it, your inclusions, that's motion and that. These are things that make rougher rocks and things, as opposed to your perfect gemmy crystals.
And with every crystal growing kit that I've ever seen, it depends on water to be the transportation thing. That's the thing that's allowing the the slurry to happen. Like you can't really make a slurry very well without water or some kind of a
Well,
liquid in
that's
there to
because
get
of
the things
our
to move around.
that's our natural little electric force and that pulling down on it, and that again you want to take away some of the force pulling down and give it room and moisture and everything to work with the ingredients. And again, water is life. Let's face it, water is life.
Mm-hmm.
Mm-hmm. Water is a liquid crystal.
Mm-hmm. I mean, water in itself is one of the ingredients. If you take the water away from the mixture, you take the life in the.
Yeah, I didn't quite think about it that way with ice. Yeah, kind of water being a liquid crystal.
Mm-hmm. Yeah, water and mercury are the only two things that are considered liquid crystal.
That's interesting to think about it that way. Yeah.
Liquid Crystal. It's the
I
name
was
of a band
watching.
right there, or at least a cool song.
I was frustrated because I was watching something came up, and I don't even remember because I watched so many of them. But one of the ones came up, and it was like these little experiments. And it's like, oh, I want to do that. And of course, they go, and they're like, oh, okay. And then you just need this, and then you just pour in an inch of mercury, and that, and it's like, yeah, I'll just grab an inch of mercury. But they were doing it pretty much like you just go down to the drugstore and get it, and that's what you used to do. At the time the video
We
was
just
made.
had mercury on hand at the drugstore for just anyone. You didn't need a prescription or anything like that.
Mm-hmm.
No,
Wow.
no. There are a lot of different uses in that for it. So yeah.
Yeah, it's crazy how dumbed down we are. Gotta make
Just how restricted we are. I think
Mhm.
that's right.
Yeah.
There.
Yeah.
Just how there's so many things that you just can't get over the counter anymore. I was
no, but it is because we're dumbed down. They used to
Mhm.
say, "Here, this is how you change the liquid, the water in your battery, and change out the battery acid for your car." That used to be in the manual. Now all it says is, "Don't drink it." I mean,
Yeah. Take
it's
it to the car place,
yeah.
return
Somebody
it.
else will do it. Yep. They don't want you to know how to think for yourself to actually figure problems out and solve things, because then you're going to realize what they're doing.
Well, and it's like they don't want you, they want to enforce their planned obsolescence and like make you buy new stuff and
Mm-hmm.
make old stuff obsolete. And so if you don't know how to fix it, you got to keep buying new shit.
So everything breaks
And
in about.
we have several generations that are coming up that not only all of them think they are the smartest generation. We are all trained that we are the smartest generation that has ever lived, that has ever graced this realm. I'm here to tell you, I don't think we are. I don't think I am. At least I don't think my generation is, and I don't think any of the generations that
if the power grid died today,
if the power grid died today, I think that they have convinced us by the fact that we can go and memorize a bunch of things that are meaningless, and literally not only are they meaningless, but they are not only meaningless, but they are evilly meaningless. We can wrap our head around the idea of the black holes and the way space works, and again the way they make everything trillions of light years away, and again what you need to wrap your head around. So they convince you that if you can do the math for this, or you pretend that you think you can understand a black hole or how all of this works, you are so brilliant, and you are special if you can write the math down. All the while, nobody knows how to do anything, knows how each person has a sliver of, they've compartmentalized us into nothing other than, again, repeating facts that most of them are complete lies and are ways just to have your brain not work. And working in that way and accepting that it does work that way, you've shut down all of your connections in your brain with reality. If you can look and think that you're on a spinning water ball, that's how, again, if you look at the facts of a globe Earth, and we've all gone over them 100 times, but if you can look at these crazy facts, and any one of you would be better at listing them out one by one with me, but looking at a sun that's like 8 light minutes away and is so much huger, and the light gets here perfectly, and yet you have things that are over 1,000 light years away that are visible the same size in the sky as things that are, again, the change in what happens in light minutes, apply it in any space of the globe Earth. If you're thinking room velocity and physics and rotational, any given slice of it doesn't work. So again, when you convince and learn these facts of it, you're convincing yourself reality doesn't work. So you're training your brain to accept absurdity. So they have this generation trained to accept absurdity, and the more absurd it is, the more acceptable they should be of it right now. So we have a generation now that thinks that boys can be girls and girls can be boys. It's a mixed up world, except for Lola.
You can change your gender, but you can't change your race, right?
Big shout
But
out.
no, just that
Green
that's
Page, 1999. Thank you so much. Regarding gas pressure and the dichotomy of flat globe Earth. Now, this is their opinion. They say you physically cross over the barrier, right? Even a gradual gradient. The spacecraft should explode at the event horizon. Respectfully. Yeah, I've never really even thought about it. Like, I've never really thought about if you actually went down to zero. Well, they don't even really claim that it's zero pressure either. It's 10 to the negative 17 torr or something like that. That's still a positive number. Even though there's that negative in there, that just means that they move that decimal point over that many places 17 times, but it's still a positive number. It's just a really, really, really small number, they say.
and
That's
again, this is
76 quintillion times the difference. 76 quintillion.
Quintillion.
and this is again the way our schools teach us how to think and think about what you're learning right there. That negative, that we're taught negatives are negative numbers, even though it's not really a negative. The numbers we have here are, again, just parse that whole idea of what they just did in science. But I digress, right?
Well, I don't know how we got off on the geology, and then we just rambled on into. But
start talking about rocks, and we.
Yeah, I know. Once we started a conversation of rocks, especially with these two ladies on the panel,
Yeah.
they love their rocks. No, it's great.
The missing link number 11 right there is the one that talks about maps. If you go up one.
This one.
Yeah, that one gets into the history of maps, and that's where it starts talking about planispheres and stuff.
Very cool. I was going to do this one real quick.
Okay.
The moon, and I figured we could end it on that. I'll just play this out. This one is about the sun and the moon, the tortoise and the hare, the speed, and it's kind of setting it up for the next couple. What is it, 7? So I don't know if this was the one setting it up. I know he finishes off with the moon. And this one right here, Twinkle, Twinkle, Little Star, that one has a lot to do with the planispheres. But yeah, I think this is the one that starts off the planisphere. Or what is it, Mapping 101? Is that the one, Kyle?
Mapping 101 is kind of an intro, but the missing link right up above it, right there, that one's the one that really takes off and really gets into the interesting stuff when it comes to I really enjoyed the depth of the flat Earth maps that he gets into, just the history of them, and then taking it to the next level and talking about mapping the stars over the flat Earth map.
Yeah, he started doing it. I don't know if he ever finished. He ran into a lot of weird stuff that, I don't know, just about the southern stars and this and that, and how, just weird stuff.
It talks about southern stars in his series here, and but when it comes to really understanding planispheres, there's 2 major concepts that I consider just to be absolutely prerequisite. One is understanding just kind of the whole counterclockwise and clockwise star rotation, because if you don't understand that, you're not going to get this whole thing right here. And then the other thing is those personal domes of vision, which is not talking about like the firmament or anything like that. That's something else. But anytime someone mentions a personal dome of vision, they're just talking about your unique perspective compared to someone else. Because
the distance your eyes can see. We can't see forever. There's a vanishing point, so it's just as far as you can see in every direction. And it would probably actually be closer at the bottom. So it would start off like probably like that at an angle and get a little bit wider as you're going up to a certain degree, and then I bet it would level off because the atmosphere is a lot thicker and you can't see through nearly as much as you can if you're looking straight up, allegedly. I don't know.
Now, Jaren's got a really good video on personal domes of vision that he really kind of just breaks it down really well, and he's got good animations for everything. But,
Yeah, so okay, I guess I don't think Adam would mind. I guess we could play this whole thing out. Because, this is a great one. All the different flat Earth maps and whatnot.
Yeah, these are like flat Earth essentials right here when it comes to really understanding things. And I just love the whole concept of, these are actual like flat Earth predictions. We are able to predict star charts, and these are our flat Earth star charts. And like they're part of our model. Kind of star rotation is part of our model. And it really kind of gets into that. And because these are like some of like the very first things a lot of the globe earthers will try to smack talk the flat Earth with. Oh, you guys don't understand this, and you don't. I'm like, come on, this is part of our model here. don't give me that crap.
Yeah.
Okay, Adam has personally given me permission to play any of his stuff on my channels at any time with no restrictions,
we need to put
and he's
them all
never
on
retracted
the
that.
24/7.
They can all go on the 24/7. That's not a problem with it. He's, again, one of the most decent, good people to work with. If we are playing it through, do we want to say our good nights now, or are we
We'll
going
say
to
our
go
good
through
night
the...
now, and then I'm probably going to just hang out and chat. I'll probably get off here, but I'm just going to hang out in the chat.
Okay, I'm going to start with the good nights before we do everybody. My good nights are just saying why I have your attention. Polarizing film sheets for everybody that wants to know what to buy, that you can buy as far as doing any of the linear polarization stuff we're talking about, and a way to do it without investing a lot of money. What these are is just literally, can you bring that up on like Amazon or that? Type in polarized film sheets, anyone? I'm a pain in the butt. I can probably, if you want me.
You could, couldn't you?
Yeah, I probably could. I thought you might, because I'm on a separate thing, but here. We're saying that because there's still time before the...
Got some great big ones.
There you go.
Eclipse. So here, let me share my screen.
Oh, nice.
Yeah. They kind of got warped in the mail a little bit, though. Heat doesn't do very nice things to them. But
we'll show you, perfect. We'll show you, Karen, too, what you have coming. And
Japan didn't have fog lights on their cars for years. Yeah, they didn't have seatbelts on the cars here in the United States for a very long time.
Okay, do you have my screen up?
Yes, you are presenting.
I am presenting these ones. We'll bring up the things too on the accounts listing, because we'll see, like, I think these ones here I've probably at least like 6 or 7 times. I'm not sure on the different, that's maybe not the 3-piece. That's like a bigger 7.8 by 11 inches, but you have different things. You'll see you have different sizes, different quantities. This one that you see purchased April 2024, this is something that will be in my house tomorrow. It's polarizing film with a 0-degree line, high transmissible, cuttable. It's A4 sheets, so they're a bigger size, and it's just a little finer calibrated on it. The other ones are just fine. This is just getting a little bit, one could do any one of these will work, and you'll see there's a bunch of them that are like the set of 10.
Yeah, the ones I got came kind of, they bent it on me, and so I'm all upset about that because it's just gonna stuffed it in my mailbox like that, and this thing is very good packaging, and so now I've got air bubbles all over one of them, and it's just annoying.
It might have a plastic film that's
Film
like a
on it,
protective
yeah.
film. And you
Right.
could probably
I
take
hope
it
so.
off.
You peel it off.
That's probably what it
Take
is.
it off, and it'll probably
Okay.
be back to normal.
So I can just peel it off, and I don't have to worry about it.
Yep.
Exactly. In fact, it
I
would be
think it's a
all
protective
better.
film. Yeah.
hmm
Okay,
And I guarantee you it's there. It's on all of them. I usually sometimes will play with them with my fingers and that with it on there before I use it for like demo work and that. I like to peel them before doing, when I'm demoing people. But again, I play with them so much. But these, again, you can get 10 of them for $12.
I was worried that peeling it off might break.
You get polarized sheet film or polarized film sheet is what it's called. And all kinds of any size you want and different things on it. People ask me a lot, so that's what I'm going to use my device to do is to answer that and just bring up how easy it is. Zach said we should do a link. There is that one. The other thing that people ask me a lot, I don't think is available anymore, but we'll look.
Miroscope.
You can see different ones I purchased. They were out of stock. They are back in now.
Price went up big time.
Price went up big time. Used to get them when we were handing them out when they were, $6.99 and $4.99 for the little ones. But these are itty bitty ones that are this. I used to have a heavy duty 8-inch one. Do you remember what we did? The thermometer.
Mhm.
We left that outside, and I left a penny in it or a dime, and the sun caught the metal in there and cut a groove, a line, perfectly grooved line through my blast really
With
good.
the
Oh
sun,
no.
as the sun moved over it.
As the
Yeah.
sun moved over, we got to see the exact sun path. It literally cut through the plastic. I've not been able to find that was from Think Geek, and was much better quality than any of those at the time. That was probably a $50 or $60 one, but they're not available. They have no good ones. If anybody wants to know my wish list, my number one wish list for something would be something like this in metal, where I could rhodium finish the inside, because of the fact that plastic, we get a lot of beautiful illusions and optical illusions with plastics, but if we add a little bit of metal to the mix, these are parabolic functions, and we can pull out a whole lot more of the wave functions. We do know that temperature transfers on this. If you put a piece of ice in a double parabolic dish, the hologram of it or the illusion of it will actually be colder. You can measure it, physically measure cold or heat or different things with it. If you were to change your properties from running on a cheap plastic with a mirror finish to an actual piece of metal with like a rhodium or a platinum finish, again, you would get a lot more function out of it. So that would be like my number one. Anybody knowing how to do, if they had a 3D printer or something, it wouldn't have to be big. It just would have to work. With that, I'm ending it.
Okay. All right. So, Karen B,
Mm-hmm.
when do you think we'll be seeing any footage? And I take it Monday there will be no coffee talk this week.
There's not gonna be a coffee talk on Monday. That's
What
for
about a
sure.
Tuesday night show? Do you think you'll
There
have
will
enough
be-
energy?
Yeah, we'll be doing a Strange World on Tuesday evening.
Awesome. Very cool. So no coffee talk.
No coffee talk. There will
For Monday,
probably be an anti-religious scripture study Saturday. And then that'll probably be it until Tuesday night.
Okay.
Then we're off to Eclipse Adventure, and then hopefully that goes well.
It will. Yes.
I'm
Safe
hoping
travels and enjoy.
all the scary talk will make people stay home, and it'll
Yeah,
actually
that'd be
pretty
great,
cool.
isn't it? Yeah, you have the whole place to yourself. That'd be awesome.
Yeah.
Oh. Kyle, anything exciting coming up this week you want to share? Any new videos you got planned coming out? Anything like that?
I'm going to be talking a lot more about Newton's laws and sharing some more of these resolutions that I've been able to attain with people concerning, particularly this next one is going to be about Newton's second law, which is pretty interesting, the whole F equals ma thing. And yeah, it's fun to see that with people actually changing your mind. That's the one thing Mark Sargent was saying, that you'll never ever see this happen where they'll change their minds right in front of you. It's always going to be in a dark corner somewhere. And yeah, it's not always the case. And so it's really fun that way. I think, yeah, there's something to this whole common ground approach with people.
Very awesome. And as for me, I'll be on tomorrow morning, 5 a.m. Eastern, over at Ironworks. You can find us at freeworld.fm. Very cool new truther, free speech station. Started by a truther that we knew for years, right from the beginning, Billy Ray Valentine. Really cool guy. I know it's got the globe logo as part of the logo for it, which we've been discussing that with him every now and then. But he does have the Sasquatch walking by, like, as soon as you go to the website. But yeah, it's free to sign up. You can get a name, and the chat's fun. It's got the GIFs and all that kind of stuff in it, and you can put your own pictures in there and share pictures while you're chatting and stuff. It's really cool. So yeah, go check that out. I know Wayne McCroy is over there. He does a show like all the time. He's over there. I forget what time it is. But yeah, freeworld.fm, or we're back. We're out of YouTube jail. We're back on our main channel again over at Iron Realm Media. We have fun. Me, Josh, and Walt. It's fun in the early AMs. We kind of just say whatever we want, and we get put in timeout quite a bit. You know, they've taken down like half of our old videos.
I'm not surprised.
It's 4 shows a week. Yeah, 4 shows a week altogether. 3 during the morning, and then it used to be 3 shows a week. 2 Tuesdays and Fridays, and then Friday night. And they've taken down like half of our shows from years ago now. We just keep getting strikes.
Do you want me to peel that for you?
Yeah, it's crazy.
Oops.
You have
Sorry,
to. I hope you have backups to all that stuff. I know it's hard to keep all that kind of stuff saved, but yeah.
Yeah, I know Josh has them all backed up somewhere, and I think Walt does too on some hard drive somewhere. But you know how that is when you start.
Yeah. That's what I'm
the
trying
hard
to.
drives used to be a lot smaller.
That's what I'm trying to save to multiple platforms all at once. Like every video, I'm doing like
smart.
4 different platforms, and that way, yeah, if it gets taken down on one of them, yeah, it's not going to happen on all 4 platforms at the same time.
Yeah.
Usually only YouTube is taking stuff down. They're the only ones who ever take my stuff down.
Yeah,
and
they're
my
bad
stuff will be
about
on
it.
Facebook. It's on Twitter now.
Yeah, the good
It's
old
only
days
YouTube.
of Flat Earth on YouTube are gone. Like, it used
Yeah.
to be awesome. Like, you just hit Flat Earth, and they would just keep feeding you video after video after video after video. And now it's like anti-Flat Earth video after anti-Flat Earth
It's all
video for
Professor
pages
Dave,
and pages.
Slam
Yeah,
and Dan.
it's
horrid.
It's horrid. It is. But what are you gonna do? Hey, we're still
alive and kicking.
Yeah,
Really hard.
I mean, they're still growing. The numbers are just growing. All I hear all day is pop, 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 pop on David's app. I turned it back on. Dude, that thing's going crazy. Like, it's insane the number of. He said it's the first time people are using it. So it could be people that have had the app already for a long time, but are now just getting the friend finder, and they're using their friend finder for the first time. But it's insane how many people are signing up and joining, and yeah, it's really coming along well. And he's adding more, of course, Dave, adding more and more. He's not going to be done with that thing ever. It's never going to be like a finished app.
Well, you gotta draw the line somewhere, because then it gets too robust. Where
it's going to do too much, and the phones aren't going to
be.
be. Yeah, but he's gotten a lot of that worked out. It didn't run down my phone either. I have it turned on, and it was running down my battery before a lot. And I just let Dave know about it, and then eventually, yeah, I turned it back on, and now it's not doing it. So yeah.
Yeah, there's a lot of refinement that goes into that, and it just keeps getting better and better. Like he puts a lot of effort into that.
Mm-hmm. Well, all right, folks, that's gonna do it. We're gonna finish you out though with this video though. It's the missing link, Flat Earth Smarts. It's AJC 1844. Was an awesome channel. Just an awesome. It's 14 videos altogether. You could do it in a day, no problem. And I guarantee you'll learn something and hear something that you probably had never heard before.
The missing link is where it really gets good for me because, like I said, there's a lot of fluff that for seasoned flat earthers, it's like, okay, let's get to the good stuff, and that's where it really picks up and gets the good stuff.
Yeah, he gets deep into it. I know this one's great too, and this one.
Yeah.
These last three right here are really, yeah.
All these ones about planispheres, they're amazing.
So you guys have a great rest of your week. Yeah. We will be back again next week. GLOBEBUSTERS Tech. Let's see. Gosh, it's been a couple weeks since we've seen you guys. Be good to each other. Don't lie to each other. Open your mind because there's truth inside. Peace out, everyone.
Peace and war against NASA.
Welcome back. So here we are again, still on the trail of an elusive map, and we still seem to hear the same arguments going nowhere fast. So what are we to do? As I've mentioned a couple of times, we don't need a map, but it's a nice thing to have. And anyone who's taken a mild interest in the matter will probably have seen enough maps to last them a lifetime. I also recall saying that none of us, myself included, are likely to go out and create a new map of the world anytime soon. But of all the maps that are kicking around, we can probably get a good idea of what's out there. So I'll cut to the chase. Back in episode 6, I showed why I think that the only maps that might help us are the circular maps, where it's back to the globe again. The dew line across the top of Canada seems to preclude all the flat maps that have the North Pole at the edge or at one of the corners. If you believe that the world is flat, I would suggest that the circular layout is the only one that gives us a start point. So let's pick this up where we left off. The circular layout seems to date as far back as 1781. That's the oldest reliable map that I can find so far, and it seems like as good a start point as any other. The layout seems to have a fairly consistent track record. So let's dig a bit deeper. I'm going to use Alex Gleason's map again, because it's still the cleanest map that I can find, and I think it still has a few more treasures for us to find. Aside from being a fairly clean map, Alex Gleason's map is also quite distinctive. That big red border around the edge tends to make it stand out from the others. And perhaps it's because it is rather distinctive that people tend to name this one when the circular map is called into question. You've all heard the disparaging remarks where people have variously referred to it as the Lil Pizza Pan model or the Lil Snow Globe map, and presumably in some vain attempt to discourage people from using it. Before I go any further, I'd like to provide a caveat. I know there are problems with making a final map. 1/4 of the known world is effectively out of bounds. Many flat earthers still seem reluctant to accept any model, but we shouldn't let it deter us from working to solve as much of the puzzle as we can. Some people do prefer to have something to work with, and for that reason, we look closer. Alex Gleason created his map at the end of the 19th century, as the basis for a timekeeping device that he patented. I'll deal with the layout in detail in a moment, but I invite you to pause for a moment and think how many agencies use this layout already. There certainly seems to be something in it. It seems that many of the critics direct their objections at Alex Gleason rather than the layout itself. If anyone still thinks this map is so grossly wrong, I would challenge them to go and bang on the door of the United Nations and ask them why they have a Lil Pizza Pan map for so many of their agencies. I recall saying some time ago that some men really do have a thing about size, and as such, do any of us really think any country would have allowed themselves to be portrayed as significantly smaller than they or their neighbours really are? It seems unlikely, so the UN map might be a fairly good indicator that we're on the right track. If we take a look at Alex Gleason's map, we can see that it was created as the basis for a timekeeping device that he patented in the 1890s. Unfortunately, it seems like the copy we have is the only surviving original, courtesy of the Boston Library. It's a little trashed, but if you do a patent search, it's fairly easy to see exactly what its purpose was. The map, which forms the central section of the chart, was created by one J.S. Christopher, but there seems to be no information available about this particular individual. Any claim that Modern College is a misspelling of Morden College, which is just outside London, is equally credible, given that the map appears to have been designed in England and then printed in the United States. It's not unreasonable for the US printers to have assumed that Morden was a misspelling and to have made the correction themselves. In either case, Morden College was originally opened, quote, for the poor merchants and such as have lost their estates by accidents, dangers, and perils of the seas. So it's quite reasonable to conclude that whoever J.S. Christopher was, he or she is quite likely to have had some considerable experience of the oceans and the maps of the world. And while the critics of Morden College now seem to paint it as being full of dribbling pensioners, it has a very credible pedigree linked to world navigation. I've trimmed Alex Gleason's chart as far as the border because I thought it might be nice to see exactly what Alex Gleason did create, and in the hope that it will provide a solid point from which we can take a closer look. In the top left-hand corner, Alex Gleason states that the chart is a longitude and time calculator. If you do a patent search, you can find these instructions for yourself, but I'll ask you to accept my assertions for a moment, and I'll put the patent application at the end for those of you who would like to see it a little closer. The chart was originally built with two arms that are pivoted near the center. They look like they're slightly off-center, but a closer look will show that they're fixed this way so that the scales on each arm run directly from the center of the map along the lines of longitude. Essentially, both arms are the same, and each one has a scale that's divided into sections to represent latitude markings and working in both directions from a 0 point at the equator. Around the outside of the chart is a scale that shows longitude markers in 5-degree steps and longitude lines at 15-degree intervals. So the first function of the chart, to calculate the longitude for any location, needs that we simply rotate one of the arms so that the graded edge runs through the location that we're looking at. The exact location can then be read off the chart as a coordinate. By way of an example, let's suppose we use Philadelphia in North America. By rotating one of the arms round so that it runs through Philadelphia, we can see from the main grid that it stands on the 75-degree line. And by reading the latitude marking from the scale on the arm, we can see that it lies at a latitude of 40 degrees north. The full coordinates for Philadelphia are longitude 75 degrees west and latitude 40 degrees north. It really is that simple. The time calculator is just as easy, almost painfully easy. Take any two locations on the map that you want to compare and rotate each of the arms so that one arm runs through each location. The tips of the arms end at the clock scale around the edge, so the time difference between the two locations is shown by counting the numbers of hours between the two arms. Again, by way of an example, let's suppose we want to compare London and Philadelphia. If we rotate the arms so that one rests over each location and count the hours between them, we'll see that they are 5 hours apart. The calculation part comes by using the scale around the outside edge like a clock. A spring washer keeps the arms the same distance apart, in this case 5 hours. I'll assume that we're in London at 3 p.m. and rotate the arms so that the later arm is moved to 3 p.m. on the clock dial, and the Philadelphia arm will show that the time there is 10 a.m. Remember, some countries use daylight savings time. As complicated as it may have appeared, Alex Gleason's time chart really is that simple. In fact, if you take a look at the patent application, he states that it really is simple enough for a child to use and no harder than reading the time from the face of a clock. If you take a closer look at the patent application, you'll notice that the accompanying map doesn't have quite as much detail as the poster version that most of us have seen. I can only hazard a guess as to why there's so much more information on the poster version, but given that no one else seems to have staked any claim to it, I'm inclined to believe that it was developed a little further when the poster version was produced to include some of the additional information around the main layout. Alex Gleason also seems to have been sufficiently satisfied that the entire layout was his invention to have placed his name at the top and to add the title that it serves as a new standard map of the world. As I said a moment ago, Alex Gleason's map is remarkable largely because it's quite distinctive. It seems that much of the opposition appears to be directed at Alex Gleason rather than the layout itself. So let's see if we can take some of the heat out of it and concentrate on the facts. The best copy that we have has the remains of one of the original arms. A nice touch, but a bit of a distraction for our purposes. So let's get rid of the arm and clean it up a bit. If we trim all the extras away, we can concentrate on the map itself. And if I trace the layout, we can pull the map away, and it's no longer Alex Gleason's map. In fact, it's nobody's map now. All I want to preserve is the layout of the land masses themselves. I'll explain why in a moment. I've also taken the liberty of putting Mount Meru back at the North Pole as an alternative to the blank, empty space that the globe seems to suggest. Much of the detail comes from Mercator's maps of the 16th century, while modern science seems to suggest that the North Pole has sunk in the last 500 years, and Father Christmas has moved his elves and his operational headquarters to Lapland. We now have what is generically referred to as an azimuthal equidistant projection, and I'm quite particular to use that word at this stage because in Alex Gleason's patent application, he states that the longitude lines from the globe have simply been straightened out. So let's take this one step at a time and not judge him too harshly. We have a flat disk that shows the land masses around the world. For our purposes, it's as good as any other map of the world. It shows the principal land masses in relation to each other, and it's flat. So I'd like to call Alex Gleason up one last time before we let him rest in peace and take a closer look at his patent application. When someone files a patent application, the date that it's filed is recorded to avoid people stealing an idea while an application is processed or pending. As such, the date that a patent is filed and the date that it's finally allowed to stand are usually some time apart. It's the date allowed that matters most because it's the earliest date that the invention is considered to exist. The more eagle-eyed among you may have noticed that the application date and the allowed date are some 6 months apart. Now you know why. If you want to patent something that includes parts that were invented by someone else, you must cite the patent number for each of those parts. You can't put a new patent on someone else's invention. You can only patent your own bits. When you apply for a patent, your application must cite the patent numbers for any part of your design that was made by someone else. At the bottom of many patent applications, you will see the numbers for those patents that are cited. So let's see if anyone else thinks Alex Gleason's layout is credible. If you run a search on the internet using Alex Gleason's patent number, you'll find that there are 3 patents that use his map, all granted in the 1970s for a device called a Universal Planisphere Complete Guidance and Computer System that was invented by one William A. Eisenhower. A planisphere is a flat map of a spherical surface. A planisphere and a globe both show the same information, except that one of them is flat and the other is spherical. If you believe that the Earth is flat, it's reasonable to accept that a planisphere serves the same purpose as the globe does for those who still think we live on a little ball. That's your decision to make. The planispheres we've seen so far are all maps of the ground, so I'd like to step away from ground maps for a moment and set our sights a little higher, several thousand miles higher to be precise. In the same way that the flat, circular world has been wrapped around a ball to provide us with a model for the globe, the skies have also been portrayed as a sphere that surrounds the globe. And in the same way that a globe can be shown as a flat, circular map, so too can the skies. I know that many people, especially flat earthers, will shout that the skies don't tell us anything about the Earth on which we live, but I would beg to differ. The sky, and specifically the sun, the moon, and the stars, have long been used in navigation to tell us exactly where we are on the surface of the Earth. If we know exactly where the sun, moon, and stars are on any date and time, it's fairly easy to establish your exact position on the face of the Earth. They provide us with a reference system. In the same way that the ground can be mapped as a planisphere, so too can the skies, and when the two are used together, they provide an extremely reliable indicator of exactly where you are on the face of the Earth. So I invite you to think about how we navigate around the world. Most people accept that GPS and local maps will generally get you from A to B. But let's remember that GPS is a fairly modern invention. On the land, navigation is fairly straightforward. In towns and cities, we follow roads and landmarks, and out in the open countryside, where there are few recognizable points of reference, we use a map and compass. Every good navigator knows that following a compass needle seems like a good idea, but that it's practically impossible to keep a steady compass while you walk. The correct method to navigate with a compass is to take general compass direction from the map, let the compass point in that direction, and pick a landmark to which the compass is pointing. Navigation is then as simple as walking to that landmark, and any route over the land is simply a case of walking from point to point until you get to your destination. On the oceans, navigation is a little more precarious because there are no recognizable landmarks. The earliest navigation over the seas relied on staying within sighting distance of the land masses. The magnetic compass began to be used for navigation at sea around 1,000 years ago, but wind and sea currents meant that sailing by the compass, or dead reckoning, was still quite hazardous for the navigator until reliable clocks were invented in the 18th century. As such, there was very little by which a navigator could be sure of his position on the oceans, except for using the sun, the moon, and the stars. They are sufficient to help navigators across the empty expanses of ocean until a lookout saw land. Radar was developed during the Second World War to provide radio beacons to mark the coastlines of the world, and now, by whatever means, GPS provides a fairly accurate referencing system across the whole world. Most modern navigators rely on GPS, but any good navigator will at least have a working knowledge of the lights in the sky for emergencies. The sun, the moon, and the stars all follow very precise patterns in the sky, and if you know where they are at any point in time, they can be used to calculate exactly where you are. Navigation needs only to head in the direction in which the compass is pointing, and use the sun, moon, and stars as markers to check that you don't stray too far from your planned course. Knowing where each of them are for any particular time and date has long been calculated by the astronomical and naval institutions of the world, and to find where they are on any particular time and date we use an ephemeris. No, not a feminist, an ephemeris. An ephemeris is a detailed set of tables from which a navigator can calculate their position anywhere on the Earth. Unfortunately, and because the sky is constantly moving, it requires some 20-odd calculations for every single position, and hence the need for good navigators on the oceans. During daylight hours, navigation is reliant on the sun and occasionally the moon. At night, the stars provide so much more information, but the calculations are still subject to mistakes. So in 1975, Mr. William Eisenhower patented his Universal Planisphere Complete Guidance and Computer System. It looks rather complicated, so let's simplify it a little. Essentially, it's a series of disks that are riveted together so they can rotate over each other. The principal disks show the sun and the moon positions in the sky, and 2 disks show the principal stars and constellations in the night sky. Another disk shows the surface of the Earth and the principal land masses. If you look closely, you'll recognize the land masses match those that are shown on the familiar AE map. In other words, the AE map and its relative proportions are considered to be accurate enough for the purposes of world navigation. Despite this only having been invented in the 1970s, this navigation tool became obsolete when GPS was rolled out in the 1990s. It did go into production for a short time, but I was only able to find one that is still in existence. The plans here can be found on the original patent application, but they don't do it much justice, so I figured it might be nice to see what a real one looks like. It measures 16 inches across, so as you can probably imagine, it doesn't contain, nor does it need to show, any inland details. For all practical purposes, it needs only to show the coastlines of the world continents. Remember, ships stop when they reach the land. For anyone who takes a moment to look at the patent application, you'll read that it can be used to show which lights in the sky are above which points on the Earth, and conversely, which points on the Earth are below the various lights in the sky. It shows what the sky looks like from the ground. So, in closing, the flat, circular map of the world seems to have a fairly reliable track record for the purposes of navigation around the world when coupled with the lights that we all see in the sky. Given that 1/4 of our world is still effectively out of bounds, this is certainly not an assertion by me that this is what a full map of the world looks like, but it does seem to add one more piece to the puzzle. If you believe that the world is flat, I would suggest that the flat, circular layout provides an accurate indication of how the various continents are placed in relation to each other. But that's your decision to make. The lights in the sky can tell us nothing in themselves of the shape of the Earth, but they certainly do provide us with a reliable reference system. Perhaps the lights in the sky have more to tell us. Thank you for listening.